Hey, hi guys. Today we will be going through large language model, that is LLM, which has been a hot topic in the IT industry. How does that work? How the things hangs together? So what the LLM means is it's a large language model. It's a type of artificial intelligence designed to understand and generate human languages. Example could be ChatGPT, Google Gemini, which everyone is using these days. It uses deep learning. Deep learning is based on neural networks. We'll go through that in detail. The architecture that it is using is transformer architecture. We'll go through that as well in the coming slide. These LLM models are trained on large amount of data. Whatever is available on internet, they have gone through it, right? May it be books, may it be GitHub code, or anything, right, that you see on internet, they have read through it, right? How do they predict the what needs to be given output to the user? It's based on on the sequence, right? If they generate a word X, how what will be they predict the next word Y with a certain probability, right? We'll go through that in the detail uh, in the coming slides. What makes LLM large, right? People think that okay, it's a large language model, right? Why it is called large? So first point is it is trained on vast amount of data. I think we already discussed LLM is trained on enormous amount of data set, may it be code, trillions of words, internet conversations, website architecture. So it has learned pattern from it, right? If someone is asking an apple, uh, so there could be two context of it, right? It could be a fruit or it could be a phone. So based upon your input, they and the conversation and the internet they have gone through, they know whether you are asking about the Apple iPhone or you are asking about the Apple fruit. Billions of parameters, right? So as we mentioned, right, it is built on deep learning neural network. There's a special type of architecture which we discussed, right? This is the transform architecture. The network has billion or even trillions of parameters. The parameters you learn various biased neural networks and determine how the model processes the information and gather the output. The more the parameter, the more complex relationship the model can learn, right? So we'll not go through into the details of the parameter as of now, because just wanted to give you a idea as to what LLM is, and so that you get a gist of it, right? Okay, moving on to the next slide. My bad. Okay, how does LLM works, right? So LLM basically, the architecture that we are discussing right now, which is the transformer architecture, it basically what it does it it is trained to predict the next word. So let's go through an example. If I can open, is it opening? Yes, I can open Chat GPT, right? Who is prime? Let's not go into technical thing. Uh, what is capital of India? Now look how ChatGPT it is giving word by word output, right? The capital of India is Delhi. Explain details about Delhi. Now look at this, right? It will print a word, then another word, then another word. It is not printing the complete sentence at once, right? What it is doing it, you are getting the output one by one. One sentence, then the next one, then the next one, then the next one. So see, look at this. Yeah, you can go government, then British. So this is what I was saying, right? It predicts the next word. So if you look at it, it is not giving you the complete output at once, right? It is there's an algorithm that is running in behind, and it is predicting the next one, and it is giving the output, right? Let's leave it over here. Just wanted to explain you what it is. Now, what is tokenization, right? There's a key concept of tokenization. So suppose you have given the input as uh, uh, where is Delhi located, right? Let's take this as input. So what chat gpt will do, or the LLM model will do, it will break this into tokens. uh, it could be one token over here, one token over here, one token, so in total four tokens, right? I'm just giving you an high level example so that you understand. So it doesn't take this as a string, right? It takes it as token. The reason of it taking it as token is because the machine doesn't understand numbers, right? So it breaks into token and then does something which we'll go through in the details, right? So it is based upon at this point I just wanted to explain you what tokenization means, right? So this why do you when you give an LLM prompt, the first step is to break down the inputs into small units called tokens. A token can be a word, a part of the word, or even punctuation. These tokens are converted into numerical representation, right? Vectors or embedding, as I mentioned, right? Machine doesn't understand your English word, right? It understands everything either by on the binary number, right? So it will convert everything into numerical representation. Now coming to the transformer architecture, right? uh, so what does transformer architecture basically do is, uh, the magic largely happens with the transformer architecture, right? Everything on the background is using the transformer architecture. The architecture is revolutionary because it can process entire sequence of text in parallel, unlike the older models. So there were some models which we were using which used to do word by word. What is good about transformer? It breaks the sentence into tokens and process all the tokens into in parallel. Now there's another concept called self attention, right? The mechanism allows the model to weigh importance of different words in the input sequence when processing each individual words. For example, in the sentence, the quick brown fox jumped over the lazy dog. When the model is processing jump, it pays more attention on the fox and the dog to understand the context rather than giving equal attention to every word. This helps the model to grasp long range dependencies and context within the text. Right, as I mentioned, if you want, if so, the quick brown fox jump over the lazy dog, right? So what it is, so here uh, one of the keyword is jump, and what it pays attention on fox and dog, right? So it is trying to derive a correlation between all these terms, which is called as an attention matrix, right? It creates of how, so this is how it understand uh, what is the context of you asking the question, right? We'll not go through the self attention in detail in this lecture. We'll go through that in the late coming lectures, right? So layer of processing, the token passes through multiple layers of neural network within the transformer. Each layer redefines, understand the relationship between word and overall meaning of the input. Right. So it goes through neural networks and then it defines. Uh, what it does is it understands the relationship between the words. So how jump is related to fox, how jump is related to dog, how dog is related to lazy. So all these words, there is a correlation created, and then with the help of correlation, it understands what is the meaning of the word. Then probability distribution. Based on everything that has been learned during the current input, the LM calculates the probability distributed over the entire vocabulary what the next token should be. So when giving you the output, right, what LLM does it generates a list of output based on a keyword. What should be the output? When we ask this question, right, explain what is the capital of Delhi. So it would have gone and then calculated the probability of the then capital of India in Delhi. Right. So first, it would have been calculated. The output will be the right. It will be based on there will be 100 word, let's say, which is expected to be an output. Then it will calculate what should be the probability of the right, and it will be highest, for example 98% probability of the, then next word capital, the probability of capital will be 99%, things like based upon that. And there could be another word, like there could be New Delhi, there could be Delhi, or probability of anything, right? So here it is a very straightforward. Let me take another example, right? uh, where is Jabalpur located? So it is, Jabalpur is located in the central part of the India in the state of Madhya Pradesh. So it is going step by step. What? So it first calculate the probability of Jabal of 10 words, and with Jabalpur came into highest probability. Then similarly this. So it is generating with each word. It is calculating what should be the probability of next word. And there is n number of words that will come into the sequence, but whichever has the highest probability, it will print that word. Yeah. Okay, I think that explains the bit. Probability distribution, token selection. The model then selects the next. So, okay, based on everything it has learned during the training and the current input, the LM calculates the probability over its entire vocabulary. What the next token should be, right? So, it has also learned, right? And I have told you that it divides the word into the statement into tokens, right? So it try to calculate what is the probability of the next token. The model then selects the next token, often based on the highest probability, which we just discussed. But sometimes it can be with a bit of randomness controlled by. So there's one parameter, right? Let's not go into the detail of that to make the output more creative and varied. Looping. This process repeats with the newly generated token being added to the sequence, and the model then predicts the next token, so on until it reaches the stopping condition. So as I mentioned, right, so when I gave the input, it generated Jabalpur as one token. Then it tried to calculate what should be the next token. Is would have been the token with the highest probability. Then located is the word with the highest probability. So this is how the output is created in transformation architecture, right? And it goes on until the stopping or certain length, the complete or center special character end of sequence is generated, right? Training and fine tuning model. So pre-training, right, this is an initial massive training, right, where you bombard the model with everything, right? It's an unlabeled data, and then you try to, so at this point of time the model is learning, right? It is trying to understand the correlation and everything, right? The background, it does all the things. Then comes the fine tuning alignment. Once you have trained, bombarded the data, you get the output from the model, right? And then you provide feedbacks from the input. Based upon that feedback, the model again learns. This is called reinforcement learning from human feedback, where the human evaluator ranks different model response, and this feedback is used further to train the model to be helpful, harmless, honest. The alignment process is what makes the model like chat gpt so good, following its engaging conversation dialogue. So the more you interact with model, the more it learns, and more it will be able to give you the correct output, right? Now coming to the application, context generation, chat GPT, everyone is using chatbots, virtual agents. I think all the websites these days has virtual agents, right? Where, for example, Zomato, when you order something, first of all, the virtual agent would come into picture, right? Summarization, you give them a text document, they will summarize everything. Translation, they can do it from different languages. Question answering, we already did. What is the capital of Delhi? We just sorry, what is the capital of India? Where is Jabalpur located? We did code generation and debugging. So nowadays a lot of code generation on the IT side is also happening using LLM models. GitHub Copilot is one of the recent example, right? Sentiment analysis, the emotional tone of price of text, whether it was spoken in positive way, neutral way, those things. Data and extraction information. So if you have a very huge amount of data, you can extract something from an unstructured text and understand what does that mean. Creative writing, you can give input to chat gpt, or write a letter to principal for my sick leave. Let's see what it says. See, it does it, right? Creative writing, which we were discussing. Moving on to my ppt, yeah, okay. Education, right? Personal training material, tutorial, and generating practices. Limitation. So not everything what ChatGPT says is correct. At time, it will tell you something which is incorrect, and it will, because it is creating the output based on the probability, right? So it, and based on the trained data. For example, if you are not using the so chat gpt would have been trained on x years of data, and if you would be asking any question that is later than that, it might either tell you that it doesn't have the information, or it can hallucinate, right? Biased. So one of the concern that could be that the data could be biased, right? It has some it is it is biased toward one of the sectors of the data, right? That which is aligning to a political party. If, let's say, if you ask a question, yeah, I'm just giving you an example, right? Or some of the rituals, right? So that is one thing. Lack of true understanding. While they generate human, like, they don't understand the world or have consequence in the human sense. So there's no intelligence, right, that we can judge. These models, these are basically mathematical modeling, right? It doesn't understand like human. So, and whenever you ask, the next is computational cost. Whenever you ask something to chat gpt, there's a computational computation happening in the background, so there's a cost involved as well. Ethical concerns around, issue around misinformation, copyright, job replacement. These are all that job displacement already happening. A lot of layoffs, a lot of people, companies are moving to AI, artificial intelligence, which they want to replace using human, right? Okay, to summarize it, LLM reverse forward AI ability to process generate human language, opening up exciting possibilities across various industries and applications. Okay, I think that was it. I think this would have helped you to get some understanding of how LLM works. We'll go through into the details of how attention matrix work, a sample code of LLM in the next lecture. Yeah. Thank you guys for your time. Yeah.